Good morning to one and all. Welcome to this online skill program on solid and surface modeling using SolidWorks. And in this session, we are going to see about the gist of the modeling. Modeling includes wireframe modeling, surface modeling, and solid modeling. And what are all these things? Let us discuss in detail about. And short animation is provided in this window. You can able to see that it's a V8 engine. So it's a V-type 8-cylinder engine, and these animations are performed in the SolidWorks itself. And you can see that it is relying as a video, but it's an animation through SolidWorks. We can do lot of things by virtually. It shows the cylinder head color as a blue and the crankcase as a red. You can see that these are all the exact. We can able to do what's the material type and how it look like. Those and all we can able to achieve through this SolidWorks. So without any delay, we can get it into the session. So before we are going to see about what is 3D modeling, so we have to know about what is modeling. So before 3D, the modeling is done with the 2D. So you can see that 2D lateral model 2.5D, it's 2.5D, the second one. It's a profile body, and the third one is a rotating body. And then after we are getting to the 3D era. So in 2D, we cannot able to visualize how it looks like in a third dimension. So and 2.5D is nothing but the what an object looks like in a 3D environment. It can be rendered in a 2D plane. So that is 2.5D, and 3D is nothing but direct visualization through X, Y and Z coordinates. ஸோ இப்போ இதில் உங்களுக்கு கிளியராக சொல்லணும் அப்படின்னா 2D அப்படிங்கிறது நம்மளோட இன்ஜினியரிங் கிராஃபிக்ஸில் லைக் பிளேட் வி ஆர் நேம் இட் ஆஸ் அ பிளேட். ஸோ நம்ம அந்த பிளேட்ஸில் யூஸ் பண்ணுறது பார்த்திங்க அப்படின்னா 2D ஸ்கெட்ச் யூஸ் பண்ணி நம்ம ட்ரா பண்ணியிருப்போம். ஸோ இப்போ அந்த 2.5Dங்கிறது 3 டைமென்ஷனல் ஆப்ஜெக்டை 2Dயில் வரைஞ்சி காட்டுறது. ஸோ அது 2.5D. அண்ட் தென் 3D இஸ் நத்திங் பட் பை யூஸிங் போத் X, Y and Z coordinates. All these three coordinates combined together to frame a 3D model. So in this 3D model, you can see that wireframe modeling, surface modeling and solid modeling is nothing but volume modeling. So solid modeling அப்படிங்கிறது it's a solid base. And then wireframe modeling. So in this 2D pictorial representation, you cannot able to visualize what is meant by 3D wireframe model and what is surface model and what is volume model. And for that purpose, I had installed SolidWorks on my PC. And while opening a SolidWorks, this is the primary window we can able to see while launching 3D SolidWorks, and I am using 2014 version. And so new document, so we have to draw in a new document. And one thing I would like to tell you that my PC have a very basic processor, and it will be a very slow one. So in between that we can go back to the presentation. And then why we have to go for 3D models. So ஏன் நம்ம 3D models போகணும் அப்படிங்கிறது தான். So these are all the parameters for getting into the 3D modeling. So 3D models are easier to interpret. Interpret is nothing but we can able to visualize on what phase the object looks like. So that can be done with the 3D model, and simulation under real life conditions, and less expensive than building a physical model. So this is the major parameter on going with the 3D models, because of we don't want to make a physical model. We don't have to manufacture a physical one for the testing purpose. Regarding this 3D models, modeling softwares, these tools are widely used, and we can say that it's a non-destructive evaluation. ஸோ நம்ம ஒரு ஆப்ஜெக்டை மேனுஃபேக்சர் பண்ணி அதோட பெர்ஃபார்மன்ஸை வந்து அதை டெஸ்ட்ராய் பண்ணி, ஸோ அண்டர் வாட் ப்ரெஷர் it can breaks, under what load it can expand. So these are all the parameters we are measuring with the physical model, and this can be achieved without destroying any physical model. So in that case 3D modeling is a primary one. And then 3D models can be used to perform finite element analysis. So finite element analysis includes lot of analysis like stress, deflection, thermal, harmonic, vibration, etc. It's a vast ocean, finite element analysis, and that can be performed with this 3D modeling. So 3D modeling will be done in a separate tools, and finite element analysis can be done in a separate tool like ANSYS, and we can able to import what are all the models are drawn with the 3D modeling software into the finite element analysis by means of exporting parameters, and we can see that in a later sessions. So and then 3D models can be used directly in manufacturing, computer, numerical control, CNC and NC. So the diagram part for drafting purpose, these 3D models are used, and with this 3D model the final draft layout can be extracted and it can be transferred into the manufacturing sessions, and can be used for presentation and marketing. Even also once a product is designed, processed and make into an end product, then it can be let out in the market by means of presentations and marketing, like I am presenting now regarding 3D SolidWorks, like that. And then 3D modeling. So it has three type of modeling. One is wireframe modeling, second one is surface modeling, and third one is solid modeling. And in this case, in the consecutive weeks of Thursday, the next Thursday and the next consecutive Thursday, we will have a practical session on 3D modeling by using SolidWorks version 2014. And on the practical sessions, we can able to visualize the wireframe modeling, surface modeling, solid modeling, etc. And if time permits, I will show a simple model as an example for all these three modeling. And now what is meant by wireframe modeling? So wireframe modeling is nothing but it consists of vertex, edges and faces, like you can see that in a example. So what is meant by edge, what is meant by vertex, and it can be easily understandable by this example. So vertex is nothing but the point. Here edge 3 is made up of V3 and V4. Simple. A point is nothing but a single point, and when it comes into a line, it consists of 2 points. The similar thing is nothing but the E6 is a line and the points are V3 and V4. The points is named as vertex and the line is joined by these two vertex, and thus the line is named as edge. So and then wireframe is a collection of edges. There is no skin defining the area between the edges. So in this case, this edge 3, edge 4, edge 2, edge 1, these are the 4 edges joining to frame a face, and in this case these corners will be notified. There will be no face and all and no solid and all, which is nothing but wireframe. And then what are all the advantages in this wireframe modeling? Can quickly and efficiently convey information than multi-view drawings. So multi-view drawings is nothing but you can say that in engineering graphics, isotropic view, orthographic view. So those are all multi-view drawings, and by using this wireframe modeling we can able to view a simple layout of an object design, and the only line scenes are the intersection of surfaces, and can be used for finite element analysis and input for CNC machines. And for manufacturing layout, a manufacturing process engineer needs only a layout or a 2D drafting only in order to carry out the process of the manufacturing of objects, and contain most of the information needed to create surface solid higher order models. And what are the disadvantages? ஸோ இப்போ நம்ம டிஸ்அட்வான்டேஜஸ்ங்கும் போது இதை நம்ம தமிழில் சொன்னால் இன்னும் ஈஸியாக உங்களுக்கு புரியும். ஸோ இப்போ வயர் ஃப்ரேம் மாடலிங் இதில் பாருங்கள். ஸோ தீஸ் ஆர் ஆல் த எக்ஸாம்பிள்ஸ் ஆஃப் அ சிங்கிள் ஆப்ஜெக்ட். ஸோ இதை 3 dimensional வியூவை நம்ம வயர் ஃப்ரேமில் பார்க்கும்போது இட் வில் கிவ் அன் ஆம்பிகுவஸ் வியூஸ். ஆம்பிகுவஸ் வியூஸ் இஸ் நத்திங் பட் the views various views of a single object which gives us a confusion. ஸோ இதை நம்ம பார்க்கும்போது கன்ஃபியூஸ் ஆகும் ஃபஸ்ட்டு இது எந்த ஆங்கிளில் ப்ரொஜெக்ட் பண்ணியிருக்காங்க அப்படிங்கிறது. So once we are very well versed in interpretation of 2D models, we can able to render what are all these objects and what are all the views are given in the diagram. and cannot model complex curved surfaces. So in the example, இது simple cube example, but இதிலே நமக்கு ambiguity இருக்கு. So இப்போ complex model போகும்போது அப்போ இன்னும் எப்படி இருக்குன்னு யோசிச்சு பாருங்க. Just think about it, how it can be a more complex one. And then uniqueness problem. So this is also another example giving a single object with a hole inside, which means the outer will be a solid one and inside will be a hollow one, which means a hole will be inside in the cubic block which cannot be seen from the outer side, and how it can be represented in the wireframe modeling. So this gives also an ambiguity. And then surface modeling. So why I'm explaining this wireframe and surface modeling, because in order to understand the solid modeling in a detailed manner, so we have to know about this wireframe and surface modeling, and so I'm giving a short explanation about wireframe and surface modeling. And then surface modeling is nothing but in a previous slide we can able to and this one, this one. So in this case, with the wireframe model, I am going to explain what is meant by surface modeling. So in this wireframe model, these 4 edges joined to represent the wireframe of a single face, and in this case there will be no face and all. If the face is present, then it will be considered as a surface modeling. ஸோ இப்போ இதில் நம்ம பார்க்குறப்போ ஒரு கியூப் இருக்குது, அந்த கியூபை சாலிட் மாடல் இருக்குது. ஸோ அந்த சாலிட் மாடல் நம்ம என்ன பண்ணுறோம் அப்படின்னா, விஷுவலைஸ் பண்ணுறதுக்கு இன்டர்னலாக எந்த ஃப்ளாஸும் இருக்காங்கிறத விஷுவலைஸ் பண்ணுறதுக்கு ஒயர் ஃப்ரேம் போவோம். ஸோ இப்போ அந்த ஒயர் ஃப்ரேம் போகிறதுனால நம்மளோட சாலிட் ஆப்ஜெக்ட்ஸை ஜஸ்ட் கார்னர்ஸ், இந்த எட்ஜஸ் மட்டும் நம்ம பார்க்க முடியும். அண்ட் இன் திஸ் கேஸ் ஆஃப் சர்ஃபேஸ் மாடலிங் we can able to view the surface of this plane. And getting back into the track of surface modeling, surface models define the surface features as well as the edges of object. So not only defines the edges, vertex of an object, but also it defines the surface features. A mathematical function describes the path of curve, parametric techniques. So we can understand what is meant by parametric techniques and parametric modeling in the consecutive slides. And surfaces are edited as single entities. And then what are all the advantages? So it eliminates ambiguity in the wireframe modeling. So wireframe modeling gives us an ambiguous views, and that can be rectified with this surface modeling, and renders a model for better visualization and presentation. Objects appear more realistic. So upon considering the wireframe modeling, this surface modeling renders the model in a better visualization and for presentation. Provides a surface geometry for CNC machining. So surface geometry, in order to visualize how the objects will be in the surface, so that can be provided with the surface modeling. And then provides a geometry needed for mold and die design, can be used to design and analyze complex free formed surfaces. And in case of wireframe modeling, there is no possibility for complex shapes, and in this case of surface modeling, this also analyzes and designs the complex free formed surfaces. For surface modeling, the examples are ship hulls, airplane fuselages and car bodies, etc. And then so car bodies also, and in this case, in this example, you can understand what is meant by surface modeling. So car bodies are made up of only a sheet metal works. It cannot be a solid one, and it consists of gauge thickness. And in the case of manufacturing technology laboratory, you can work on sheet metal works for making tray and cone, etc. So like that, it is also on a solid modeling, but that case can be treated as surface modeling in the modeling tool. Surface properties such as roughness, color and reflectivity can be assigned and demonstrated. Like in the first slide of an animation of V8 engine, you can see that the color and then the animatory effects and the reflectory, which means the shining effect of an engine components, that also can be demonstrated with the surface modeling. And what are all the disadvantages of surface modeling? Surface models provide no information about the inside of an object, which means it does not provide how the core of a solid object. So core means the internal point. So internal points are I'm representing as a நம்ம சாலிட் மாடல்ஸ் வந்து லைக் எக்ஸாம்பிள் if we take a mobile phone, so this is an example. We can see that the touch screen panel or display of the phone, and in the back case we can able to see the rear cameras and then fingerprints, sensors, and then volume rockers, etc. But now we cannot able to see the internal motherboards or battery, inbuilt battery, that and all we cannot able to visualize, we cannot see that. So that is also an example for surface. And then now we are getting into the track of the content of this session, solid models. So what are all the advantages and what are the disadvantages and what are all the things we can able to do with the solid models? We can see this. In the solid modeling, the solid definitions includes vertices, edges, surfaces, weight, and volumes. So in wireframe modeling and surface modeling, the weight and volumes surfaces are not rendered, and in case of surface modeling, surfaces includes, but in case of solid models, all this vertices, edges, surfaces, weight, and volumes are included. And now you can imagine that a simple object can be visualized in a three-dimensional as it is with the help of solid modeling. And the model is complete and unambiguous representation of a precisely enclosed and filled volume, which means, so நம்ம வந்து ஒரு 3D ஒரு ஆப்ஜெக்டை 3 டைமென்ஷனலில் எப்படி நம்ம கையில் இப்போ நேரடியாக பார்த்துட்டு இருக்கோமோ அதே மாதிரி நம்மளோட மாடலிங் டூல்லையும் கொண்டு வர முடியும். And then advantages, has all the advantages of surface models: uniqueness, non-ambiguous, realistic surface profile plus volumetric information, allows the designer to create multiple options for design. And then 2D standard drawings, assembly drawings, and exploded views are generated from a 3D model. This is another important parameter in the solid modeling. We can able to retrieve the 2D layout or draft from the generated 3D model, and also from assembly also. And then another advantages are exported to different finite element programs for analysis purpose, for analyzing a three-dimensional object. So it can be directly exported from the modeling tool, can be used in newly manufacturing techniques like sim, cam, dfm, dfa. These are all the things we can able to study in the pre-final year and final year of your UG program. So sim, computer integrated manufacturing, computer aided manufacturing. In the third year pre-final year mechanical engineering, you can able to study the computer aided manufacturing and design and etc. And then mass and volumetric properties of an object can be easily obtained: total mass, mass center, area, mass moment of inertia, volume, radius of gyration, and so on. So these are all the parameters we can able to obtain from the generated 3D model. So with the formula, the representing the what are all the things we can able to attain from the generated 3D model. And then solid model disadvantages. So what are the disadvantages includes in solid modeling? So more intensive computation than wireframe surface modelings. So since for rendering the surface reflectivity, weight, volume, edges, vertex, and the animatory effect, so it includes more computation work, requires more powerful computers in order to render the entire animatory effect. The computers, the graphics cards, and the processor should be faster than a normal or regular one. And methods for creating solid models, how the solid models can be created. So these are all the methods for creating solid models: boundary representation, constructive solid geometry, and then parametric modeling. So in this case, AutoCAD 3D modeler, constructive solid geometry techniques is used. And in this case of SolidWorks, Unigraphics, Inventor by Autodesk, or Pro-E, these CAD tools using parametric modeling. So what is the difference between BREP and then the CSG and then parametric modeling? We can see that in a consecutive slides. Solid modeling in this case of boundary representation. So it can be defined by the surfaces, edges, and surfaces. The face of boundary represents an oriented surface. There are two sides to the surface. solid side inside and the void side outside. Void side is nothing but the surface and the solid side is nothing but the core. So boundary representation model is creating using Euler operation. So what is meant by Euler operation? We can see that many finite element method programs use this method, allows the interior meshing of the volume to be more easily controlled. So boundary data structures. So this is the table representing the B-rep and consider this as a pyramid. So how it can be formed? So vertex is nothing but the points and the edge is nothing but the line joining the points. So vertex is the very primary one, and with the help of vertex we can able to form edges, and with the help of edges we can able to form faces. So இப்போ இங்க பாருங்க face table F1 அப்படிங்கிறது இந்த face. So இந்த faceல என்னென்ன edges இருக்கு? E1, E5, E6, E1, E5 and then E6. This triangle is nothing but face. And in case of edge table E1, which consists of V1 and V2 vertices, and then in case of E5, so E5, V5, V1 and V5, and in this case of E6, V5 and V2. So these are all the face table, edge table and vertex table. Vertex table is nothing but V1. So in this case for getting 3D model, V1 consists of X, Y and Z coordinates, which can be represented in the vertex table, and by this table boundary representation formed, and with the help of each boundary representation of the spaces we can able to render 3D model, and by using Euler operations. So Euler operations is nothing but how the boundary representation data structures are stored. With the help of geometric entities, they are shell, face, loop, edge and vertex. So edge and vertex, face you are well known about now, if not before. So உங்களுக்கு முன்னாடி தெரியலனாலும் இப்போ நான் சொன்ன எக்ஸ்பிளனேஷன்ல இருந்து you can able to understand what is meant by edge, vertex and face. And shell, loop is nothing but we can see that in the next slide. So this Euler Poincare formula uses to generate the geometric entities for boundary representation. V minus E plus F minus H is equal to 2 into S minus P, and V is nothing but vertices, E is nothing but edges, F is nothing but faces, H is nothing but the whole loops, and S is the shell, and P is nothing but number of passages. So like this is an example. It's a 3D model which consists of a hole at the center. So this 3D model has 16 vertices, 24 edges, 10 faces and 2 whole loops, and then 1 shell, and then 1 number of passages. So by calculating we can able to get LMS equal to RMS, LHS equal to RHS, left hand side is equal to RHS, right hand side. So in this case 16 minus 24 plus 10 minus 2 is 26 minus 26, which means 0, and 1 minus 1 0, and 2 multiply 0 is nothing but 0. So 0 equal to 0. And by this Euler Poincare formula, the boundary representation techniques were used to generate 3D model. And what are all the Euler operators and the loop? So this can be understand from this MEL. MEL is nothing but make edge loop, which means edge loop ஆ கன்வெர்ட் பண்ணு அப்படின்னு அர்த்தம். ஸோ இப்போ இது ஒரு edge, இது ஒரு vertex, இது ஒரு vertex, which combines to get a line which is nothing but edge, and this is another edge. ஸோ மேக் edge loop அப்படின்னா, ஸோ இப்போ இந்த edge என்ன பண்ணுங்க, ஜாயின் பண்ணுங்க அப்படின்னு அர்த்தம். ஸோ which means joining the edges. So which gives us MEL, Euler operator, which means make edge loop. Like this all these presentations are given here. You can able to watch this presentation in the YouTube also. Later I will upload in the channel. So and I will tell the channel name at the end of the session, so that you can able to spend more time to get easily understandable. And then constructive solid geometry, CSG. So for CSG is nothing but the Boolean operations. So with the help of Boolean operations we can able to generate the 3D model, which means union, subtract, intersections. So what is meant by union, what is meant by subtract, what is meant by intersection? With the help of a pictorial representation we can understand all this CSG. So these are the primitive solids. So these solids can be generated by use of 2D sketch. So like this is a cube, for example. I will tell this one as an example. So in this case, if we draw a rectangle and extruded to the predefined length, we can able to get cube. And this case is also similar. With the help of different extruding length, we can able to get a rectangle. Cube is nothing but all sides are equal, but in case of rectangle, the length of the object will be higher than the breadth. And this case of triangular prism, we can able to get by drawing two planes, this rectangle in a one plane and this line in a one plane, and we can have an option to merge these two planes to get this triangular prism. Like this, we can able to get all this type of three-dimensional objects with the help of 2D sketches. And this 2D sketches and then the features combined to get primitive solids. சிம்பிளாக புரிகிற மாதிரி சொல்லணும் அப்படின்னா, இந்த ஒரு ரெக்டாங்கிளை ட்ரா பண்ணி அதை நம்ம எக்ஸ்ட்ரூட் அப்படின்னா வெளியில் கொண்டு வாங்க அப்படின்னு அர்த்தம், சாலிடாக. ஸோ அப்படி கொண்டு வரும்போது நமக்கு இந்த சாலிட் ஆப்ஜெக்ட் கிடைக்குது. ஸோ இப்போ ரெக்டாங்கிளுங்கிறது ஒரு பேராமீட்டர், அண்ட் தென் இந்த எக்ஸ்ட்ரூட் அப்படிங்கிறது ஒரு ஃபீச்சர். ஸோ இப்போ அந்த ஸ்கெட்சும் ஒரு ஃபீச்சரும் combines to get primitive solids. And these are all the examples of primitive solids, and with this we can able to generate 3D model. And this type of generating 3D model is nothing but constructive solid geometry. So this is another example how we can able to get this primitive solids. And what are the Boolean operations? So this rectangle is a primitive solid 1, and this cylinder is a primitive solid 2. And going for Boolean operation, Boolean operations is nothing but that union, intersection, and then subtraction with the help of this. So when getting subtraction from A to B, so consider this as a A and this as a B minus A. So from this cylinder object, subtract this rectangular object, and so we get an subtracted portion in this cylinder. And in this case of A minus B, so from A subtract the B portion. So what are all the intersecting point and the B point can be deleted. And in this case of union, there is no need of any subtraction, so it can be combinedly joined, and the end 3D model is like this. And in this case of A intersection B, what is the common intersecting point? So like a dotted line, you can able to see that. So which means this A and B combining to get this intersecting point. So that will be the final end 3D model. And then implementing, so this is another example which is nothing but first one is with the rectangle and then cylinder, and in this case both are rectangle. And also these are all the Boolean operations like union, subtraction, those are all. Yeah, solid modeling example using CSG. So the previous slides you have seen that the wireframe model of this CSG, and now in this case you can see that in a 3D model. This is a cylinder and this is a rectangle. On union, like we can get this, and we can able to place the cylinder in this side also, and also in the reverse side. So we can able to achieve. And in this case, it is another cylinder which can be for getting this. So this is the final object we have to get. So for this, what are the primitives they are using? Cylinder and rectangular box. So first they are making this base rectangle and then the top cylinder by this union operation. And to get whole, this object is placed in this, and with the help of A minus B. So consider this a whole block as a and this as a B. So A minus B, we can able to get this whole. And for getting this cut, so another rectangular block is used, and so the final object is obtained. So for this generation of 3D model, what are the primitives they are using? Cylinders and then rectangles. With the help of this Boolean operation, we can get this 3D model. And then creating solid models with the parametric modeling. Parametric modeling is nothing but the models we are using in SolidWorks, like I am featuring now. So SolidWorks பத்தி தான் நான் இப்போ சொல்லிக்கிட்டு இருக்கேன். ஸோ இப்போ SolidWorksல என்ன டைப் ஆஃப் மாடலிங் கான்செப்ட் யூஸ் பண்ணுறாங்க அப்படின்னா this parametric modeling. So parametric modeling is nothing but we can able to achieve the 3D models with the help of sketch, features. These are all. So what is meant by sketch, what is meant by features, those are all can be seen in this software. So this is the software we are going to use to produce the 3D models, and in the consecutive session we will see this practical generation of 3D models.